All right, thank you all for coming out this evening. My name is Jared Ortiz. I teach Catholic Theology here at Hope College, and I'm the director of the St. Benedict Institute. And tonight we're very pleased to have Stephen Barr with us. We'd like to thank all of our co-sponsors, and especially the Corpus Christi Foundation. Very excited to have Dr. Barr here. As I said, I teach in the religion department, so I work with students a lot in the area of faith. And students at Hope are all over the map in terms of their faith and their faith commitment. And a lot of students have drifted away from their faith, but I would have to say that the majority of students I encounter who have a crisis of faith, as opposed to just drifting away, but the majority of them who have a crisis of faith, it's related to the questions of science. It's related to something that they learned in biology class does not square with what they heard in Sunday school class. And this creates a real bifurcation in them, and they end up tilting one way or the other, and usually away from the faith. And so I'm very, very pleased to have Dr. Barr here to talk about this. Dr. Barr is a professor in the Department of Physics and Astronomy at the University of Delaware. His physics research centers mainly on grand unified theories and cosmology of the early universe. Professor Barr has written extensively and lectured widely on the relation of science and religion. His most recent book is Modern Physics and Ancient Faith, published by the University of Notre Dame Press and also on sale in the back. He is the founding president of the Society of Catholic Scientists, an international organization which has over 1,000 members in 38 countries. Tonight, Professor Barr will speak to us on science and religion, the myth of conflict. Please help me welcome Dr. Stephen Barr.
Just want to make sure this works. Thank you for coming out to hear me tonight. Thanks, Jared and Brian Picou, for inviting me, and for all the groups on campus that are co-sponsoring this event. Before I start, how many people, well, everybody knows who the gentleman on the right is. That's Albert Einstein. How many people here know who the clergyman he's talking to is? Raise your hand if you recognize him. Good. So at least you'll learn one thing tonight. That'll be later. So many people think that there's some kind of a conflict between science and religion, and I'm sure that many of you are here because you know that there's supposed to be such a conflict. And when people find out that I am a scientist and a religious believer, they sometimes ask me whether I find any difficulty in reconciling the two. I've always found that question to be a strange one. In fact, many of my scientific colleagues who are religious get asked similar questions, and they also find it strange. Because the same thing that makes me a Catholic Christian makes me a scientist, or many of the same things: a sense of wonder, a passionate desire to know the truth, to know the reason behind things, and a deep conviction that everything holds together in some coherent way. For me, and for many religious scientists, many Christians who are scientists, the Christian faith and science are ways help us to make sense of the world. Science tells us about the things that we can observe and measure. Our faith has a much wider scope and answers deeper questions about the ultimate cause of the world's existence and order, of the purpose of human life and our ultimate destiny. It tells us about spiritual realities, about God and man, love and truth, good and evil, sin and redemption. The Christian faith and empirical science are two perspectives on reality. They see things in different, but not conflicting ways. I've been a scientist for about 41 years. I've been a Catholic for almost 66 years. And I know of no scientific fact that conflicts with any Christian doctrine, with any Catholic doctrine. So why do so many people seem to think that there is some kind of a conflict between science and religion? Well, one reason is that some people lump all religion together in an undifferentiated mass. Every example, therefore, of superstitious beliefs or magical practices they see or read about, is evidence to them of the irrationality of all religion. And many fail to see the distinction between science itself and a certain philosophy that is often called scientific materialism. What is scientific materialism? Well, materialism is the idea that all reality is reducible to matter and its behavior. Scientific materialists are people who think that materialism is somehow implied by modern science. Now, this is an opinion that's held by many scientists and by many people who claim to speak in the name of science, but it has no claim to being science. It's a philosophical stance. It's a philosophical opinion. Now, if matter were the only reality, then of course God would not exist, because God is not a material entity, nor would human spiritual souls. A human being would be, in the final analysis, nothing more than a complex structure made of atoms. And everything about a human being would be ultimately explicable in terms of the laws of physics that govern how those atoms move. In other words, scientific materialism implies not only that God does not exist, but that, strictly speaking, you don't exist either, not in the way that you thought you did. The popular astronomer and late science writer Carl Sagan put it this way once: I am a collection of water, calcium, and organic molecules, called Carl Sagan. Francis Crick, co-discoverer of DNA, wrote, "You, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. As Lewis Carroll's Alice might have phrased it, you're nothing but a pack of neurons." Now, I should emphasize that you read about atheists who are atheists because of science. Most of those, at least in my experience, are not only atheists, they're materialists, which is a much more radical viewpoint than atheism. Now, for some of its adherents, scientific materialism is more than a philosophy. It's a passionately held ideology that sees science as having a saving mission. The mission is to free the human mind from irrationality and superstition, among which they count religion. For such people, it's not enough that science is something good and brings us understanding of the world. There must be an enemy to be vanquished, and they cast religion in that role. This explains the strange zeal that some materialists, like Richard Dawkins, for example, have in propagating their ideas. They feel that they're taking part in a grand struggle between reason and its enemies. Now, scientific materialists and other atheists have a well-developed critique of religion, which has at least three aspects: philosophical, historical, and scientific. Their philosophical claim is that there is an inherent contradiction between the scientific and religious outlooks. Science is based on reason and evidence, whereas religion, they say, is irrational because it is based on dogma, faith, and mystery, which involve belief in things that cannot be seen and for which supposedly there is no evidence. Science is based on natural explanations of natural phenomena and natural laws, whereas religion is based on miracles and the supernatural. They see religion as a matter of myth and magic, and therefore the very antithesis of a rational scientific outlook. The historical claim is that religious believers and institutions have been hostile to science historically and have tried to suppress it. This is powerfully symbolized in the eyes of many people by the Catholic Church's treatment of Galileo 400 years ago. And this impression is constantly being reinforced in the public mind by the never-ending battle against evolution by fundamentalist Christians. The materialist scientific claim is that the actual discoveries of modern science over the last 400 years have debunked or undermined basic Christian beliefs about the universe and our place in it. As the story is often told, science has dealt one blow after another to the religious conception of the world. Copernicus showed that humanity is not at the center of the universe. Newtonian physics showed that nature has no purposes or goals, but is governed by blind, impersonal forces. Modern astronomy shows how small and insignificant we are compared to the cosmos as a whole. Darwin, some say, showed that human life is an accident, and human beings differ only in degree, but not in any fundamental way, from lower animals. Advances in neuroscience and artificial intelligence are thought to be demonstrating that the supposed soul is nothing more than the working of the brain, a complex biochemical computer. And modern cosmology is invoked to show that either the universe had no beginning or that the universe created itself out of nothing by a quantum fluctuation. So in this talk, I'm going to focus primarily on the materialist philosophical and historical claim that religion and Christianity in particular are inherently contrary to science and historically have been its enemies. In the last part, I hope to have enough time to discuss some of the things modern physics has discovered, especially in the 20th century, and argue that they're more consistent with what Christians believe than with materialism and atheism. So let's begin with the supposed opposition between the supernatural outlook of biblical religion and the naturalism of modern science. Now, Christianity and Judaism were never based on supernaturalism if you mean by that a rejection of the idea that there is a natural order. In fact, scholars tell us that the book of Genesis was in part an attack on the superstition and supernaturalism of ancient pagan religion. For example, when Genesis said that the sun and moon are merely lamps or lights placed by God in the heavens to light the day and the night, it was counteracting the paganism that worshipped the sun and the moon as gods. And when Genesis said that man is made in the image of God and was to exercise dominion over the animals, Genesis was, among other things, attacking the paganism in which human beings worshipped and bowed down to animals or to gods made in the image of animals. So in paganism, the world was filled with occult forces and populated by numerous deities, gods of the ocean and the forests, of wind and fire and lightning, of sex and fertility, and so on. Jews and Christians, however, taught that there was only one God who was not to be sought within nature and within its phenomena and forces, but a God who was above nature, a God who was outside of nature, and indeed a God who is the author of nature. In this way, biblical religion helped strip the physical universe of divinity so that it was no longer the abode of gods, but in the creation of one God. And so, in fact, it helped to make the physical universe into a natural world. And since God is good, the author of the physical universe, since God is good, the natural world was seen as something good and worth studying. Since God is intelligent and wise, the world he made must reflect this. It must therefore have been made according to principles and laws that can be discovered and understood by reason. Biblical religion then taught that there is a natural order that comes from God. And what characterizes this natural order and reflects the rationality of its creator is precisely that it is orderly, harmonious, and lawful. Consider this passage from the letter of Clement, who was Bishop of Rome, to the church in Corinth, and this letter was written around 97 AD. St. Clement of Rome was an early bishop of Rome, listed in ancient documents as the third after St. Peter. The heavens it's a long letter, but I'm just excerpting a very small part. The heavens, as they revolve beneath his government, do so in quiet submission to him. The day and the night run the course he has laid down for them. Sun, moon, and starry choirs roll on in harmony at his command, none swerving from his appointed orbit. Laws of the same kind sustain the fathomless deeps of the abyss and the untold regions of the netherworld. The impassable ocean and all the worlds that lie beyond it are themselves ruled by the like ordinances of the Lord. Upon all of these, the great architect and Lord of the universe has enjoined peace and harmony. Or consider this passage from the late Christian author, the Latin Christian author, Minucius Felix, writing around 200 AD, in a book addressed to those who did not believe in a creator God. He said, if upon entering some home, you saw that everything there was well tended, neat, and decorative, you would believe that some master was in charge of it, and that he was himself much superior to those good things. So too, in the home of this world, when you see providence, order, and law in the heavens and on earth, believe that there is a Lord and author of the universe more beautiful than the stars themselves and the various parts of the whole world. Now, in fact, one can come up with numerous quotes from the early church fathers from the 2nd century through the 6th century, hammering home the point. This is their main argument taken from the physical universe for God. One, that the universe exists, that it has being, there has to be a cause of its existence. And two, it is orderly. There must be a cause of its order. Now, look at what these passages I just read point to as evidence of God, not to supernatural phenomena or miraculous departures from the order of nature, but to the order of nature itself and its lawfulness. The ancient argument was that if there is a law, there must be a lawgiver. Now, God was the lawgiver to Israel, but not only to the people of Israel, but to the cosmos itself. So in Jeremiah 33:25, God says, when I have no covenant with day and night, and have given no laws to heaven and earth, then too will I reject the descendants of Jacob and of my servant David. Psalm 148 tells of God establishing the sun, the moon, the stars, and the heavens by a decree or law. The idea of God as a rational lawgiver very likely helped give birth to the idea that there are laws of nature, as even some atheists at times concede. For example, the eminent biologist Edward O. Wilson suggested, who was an atheist, or at least a strongly skeptical agnostic, suggested the following as the reason that Chinese civilization, for all of its impressive scientific achievements, did not produce an Isaac Newton or a Descartes. And he said, Chinese scholars had abandoned the idea of a supreme being with personal and creative properties. No rational author of nature existed in their universe. Consequently, the objects they meticulously described did not follow universal principles. In the absence of a compelling need for the notion of general laws, thoughts in the mind of God, so to speak, little or no search was made for them. And the well-known cosmologist, André Linde, has suggested that the notion of a universe governed, quote, by a single law in all its parts was historically rooted in monotheism. Now, our faith as Christians does, of course, teach us that there are supernatural realities, such as divine grace, that have effects in the world. But the word supernatural would have no meaning. It literally means above the natural. So it would make no sense unless there were a natural order to begin with. And the concept of miracles, which are extraordinary events, which go beyond what is naturally possible, presupposes that there is a natural order which determines what is naturally possible and what isn't. There is no contradiction logically between the idea of miracles and the idea of a lawful universe. For the same lawgiver who established the laws of nature and gave things their natural powers, can also suspend or override those laws for a great enough purpose. Because he made the rules, he can make exceptions to them. As we'll see, the men who led the development of modern science in its first few centuries, the pioneers in uncovering nature's laws, such as Isaac Newton, were almost all devout Christians who believed in miracles. There's much confusion today, even among religious believers, about how nature relates to God. Instead of seeing God as the author of nature, they see God and nature as somehow opposed or in competition with each other. So that if something has a natural explanation, then God has nothing to do with it. And if God is the cause of something, well, then it must be supernatural. So therefore, they look for evidence of God only in what is outside the course of nature or inexplicable by science. That is, in the gaps in our scientific understanding. Hence the expression of the God of the gaps. And atheists think that by closing those gaps in our understanding of the physical world, they'll leave no place for God to hide. They'll put him out of a job. The traditional Christian view is quite different. If God, as creator of the natural world, established its laws and gave things their natural powers, then his existence is evident in nature itself and its ordinary processes. This is the message of the following passage from the Book of Wisdom, a Jewish work of around 50 or 100 BC, which Catholic and Eastern Orthodox Christians regard as part of the Old Testament. For all people who were ignorant of God were foolish by nature, and they were unable from the good things that are seen to know the one who exists. Nor did they recognize the artisan while paying heed to his works. But they supposed that either fire or wind or swift air or the circle of the stars or turbulent water or the lights of heaven or the luminaries of heaven are the gods that rule the world. If through delight in the beauty of these things people assumed them to be gods, let them know how much better than these is their Lord, for the author of beauty created them. And if people were amazed at their power in working, let them perceive from them how much more powerful is the one who formed them. For from the greatness and beauty of created things comes a corresponding perception of their creator. Notice that the evidence of God to which this scriptural passage points consists of phenomena and processes that are perfectly natural. Fire, wind, swift air, the circle of the stars, turbulent water, and the lights in the heavens, or the luminaries of heaven. This is a institution founded in the Reformed tradition of Protestantism. So I'm going to quote from Calvin. Calvin, in his Institutes on the Christian Religion, said, "God has manifested himself in the formation of every part of the world, and daily presents himself to public view in such manner that they cannot open their eyes without being constrained to behold him." He's talking about the things you see every day. You can't open your eyes any time, at any place, without seeing God's work. It's in the ordinary processes of nature we find evidence for God, not just miracles or the supernatural. Whithersoever you, he continues, whithersoever you turn your eyes, there's not some atom of this world in which you cannot behold some brilliant sparks, at least, of his glory. Okay, so nature itself testifies to God. The natural order and its orderliness and its lawfulness testify to God, the lawgiver. Medieval theologians distinguish two ways in which God acts in the world. He can act directly in a supernatural manner, for example, turning water into wine, or he can accomplish his will through the operation of natural causes and processes, which in the terminology of theology are called secondary causes. God is the primary cause. Natural causes are secondary causes. It's always been the Christian view that God ordinarily acts through natural secondary causes. In the words of the scholastic theologian Francisco Suarez, who lived around 400 years ago, God does not interfere directly with the natural order, where secondary causes suffice to produce the intended effect. Now, this principle was important for the founding of science, for it implied that when confronted by some puzzling event or strange or new phenomenon, we should look first for natural explanation. Superstitious people tend to see the supernatural in every unusual or strange event. But this was criticized by the great medieval scientist theologian Nicholas Oresme. In explaining the marvels of nature, he said, quote, "There is no reason to take recourse to the heavens or to demons or to our glorious God as if he would produce these effects directly, any more than he directly produces those effects whose natural causes we believe are well known to us." Another great medieval scientist and philosopher, Jean Buridan, wrote, "The philosophers," which in those days included scientists, the philosophers explain such marvels by appropriate natural causes. But common folk, not knowing of causes, believe these phenomena are produced by a miracle of God, which is usually not true, he said. In other words, we should first seek appropriate natural causes, rather than jumping to the conclusion that something new and strange is a miracle. That's why the Catholic Church, in its canonization process for saints, does not declare a miracle worthy of belief until it has excluded the likelihood of natural explanations. Now, this brings us back to the crucial theological distinction between primary and secondary causality. I think the failure to grasp this distinction is one of the main reasons people see a conflict between science and religion. This distinction is most simply explained, I think, by a simple analogy and by using the terms vertical and horizontal cause rather than primary and secondary. So the analogy is to a play or a novel. So consider the play Hamlet. In the play Hamlet, the character Hamlet kills the character Polonius by stabbing him through a curtain. So consider the following question, and sometimes I have the audience vote. Did Polonius die because Hamlet stabbed him through a curtain? Or did Polonius die because Shakespeare wrote the play that way? See, it's an absurd question. Obviously, both. Hamlet, the character Hamlet stabbing Polonius through the curtain, is the cause within the plot of the play of Polonius dying. It's what I'll call the horizontal cause. But Shakespeare is the cause of the entire play. He is the reason there is a play. He's the reason that there are characters, Hamlet and Polonius. He's the reason that Hamlet stabs Polonius, because that's what Shakespeare wrote. He's the reason that Hamlet stabbing Polonius was the cause of Polonius dying. Now, clearly, so these are two different levels of causality. Shakespeare's the vertical cause. Now, there's no competition, obviously, between these two levels. So by analogy, the natural causes within the universe, within its plot, thinking of the universe as a great play, the causes within the plot of the universe are the natural causes that everybody and scientists in particular study. Someone lit a match and the bomb went off, and the bomb went off, and something caught on fire. Those are the natural chain of causality within the plot. But God, as the author of nature, is the vertical, or in theological terms, the primary cause of the whole thing. So this makes clear just how silly it is to treat evolution and creation as alternatives, as both fundamentalists and atheists do. Did this species of animal, say crocodiles or giraffes, did they arise by some natural sequence of causes? Or because God wrote the play, the universe that way? Because God wrote them into the script? Both. There's no contradiction. This also makes clear why scientific materialists are wrong to think that we believe in God, we quote, without evidence. For a materialist, evidence means either observing something with our senses directly or inferring the existence of something as the natural cause of what we observe. We might observe a compass needle move and infer the existence of a magnetic field as the natural cause of that. But obviously God cannot be observed or known in either of those ways. He is not something within the material world that we can observe with our senses. It's not a material object. Nor is he the natural cause of what we observe. God is not a cause within nature. God is the cause of nature. Thus, nature gives evidence of God in the same way that a play or a novel gives evidence of its author, even if the author does not appear within the plot. Or the way a symphony gives evidence of its composer, even though the composer is not among the notes of the symphony. So let's return. So that's what I'm going to say on the sort of philosophical side of things. I want to quickly go through some history. So I leave some time, I hope, for physics at the end. The idea that Christianity and the Catholic Church, perhaps in particular, opposed science and tried to hold it back is called, by historians, the Conflict Thesis. It has been rejected by contemporary historians of science as a recent invention. It's really an invention of the late 19th century. The idea that science was born in conflict with religion and that there were two warring camps, the science camp and the religion camp, is projecting onto the past ideas that arose, as I said, in the late 19th century. In the first few centuries of modern science, the scientific people were religious people. They were not in a separate camp. Consider the great figures of the scientific revolution. The scientific revolution was sparked by Copernicus in the 1500s, and the real explosion, what we call the scientific revolution, really happened during the 1600s. If we look at some of the greatest figures of the scientific revolution, I could make a longer list, but let's stick with these. Kepler was famous for his, well, first of all, Copernicus was an official of the Catholic Church. He's a canon of Frauenburg Cathedral. Johannes Kepler, famous for his 3 laws of planetary motion, was a devout Lutheran who announced the discovery of one of his laws with this prayer: I thank you, Lord God, our Creator, that you have allowed me to see the beauty in your work of creation. Galileo, despite his troubles with the church authorities, remained a devout Catholic throughout his life. In fact, when he was old and could no longer walk, he had himself carried to church to attend Mass. Descartes believed in God and that human beings possess immaterial spiritual souls, and there's no reason to doubt the sincerity of his claims that he was a believing Catholic. Blaise Pascal was not only a mathematician and physicist of genius, but a mystic whose life had been transformed by this mystical experience and who wrote in defense of Christian faith and against radical skepticism, religious skepticism. Robert Boyle, the first modern chemist, often considered the founder of chemistry, was a pious Anglican who wrote theological works and left a large sum of money to endow a series of lectures, whose purpose was to combat religious unbelief. In fact, he said that Sunday was a particularly good time to do scientific experiments because it was a form of worship. Isaac Newton, the greatest of them all, spent as much time on theological and scriptural studies as he did on mathematics, and physics. All of them saw their work as showing the beauty of God's creation, rather than as supporting atheism. For example, and this continued well beyond the 17th century, the two, by everyone's estimate, the greatest physicists of the 19th century were Michael Faraday and James Clerk Maxwell, both deeply devout Protestants. Moreover, the scientific revolution did not spring from thin air. Its foundations were laid in the universities of medieval Europe. That has been strongly emphasized by the distinguished historian of science, Edward Grant. It was in those medieval universities, which were, of course, religious institutions, that for the first time in human history, science and scientific questions were studied and taught on a continuous basis from generation to generation by a stable community of scholars. In the words of Professor Grant, the medieval universities were the first time that science was institutionalized. By the end of the Middle Ages, there were 100 universities in Europe, and they produced hundreds of thousands of graduates who were introduced to scientific questions and from whose ranks scientific talent could emerge. The scientific community and the scientific public created by these universities were the soil in which the seeds of the scientific revolution germinated. Now, I'm going to go through this very quickly because this is not a Catholic institution, but I think it's an interesting story that dramatically illustrates the positive role of religion in the development of science. It's a very little-known story, except to people who specialize in this kind of thing. And that is the large number of Catholic priests who made major discoveries, not just who were scientists, but who made major discoveries or contributions to science. So I'm going to go through a litany of them very quickly. So the first is Niels Stensen, also called Nicholas Steno. He's really one of the founders of geology. He's, if you go look at any history of geology, and he's listed often as the first among the founders of that science. He was also an important figure in the history of anatomy. He was considered the greatest anatomist of his day, and crystallography also. As an anatomist, he made major discoveries about the glandular and lymphatic system, as well as about the heart and the brain. But his greatest achievement was developing the correct theory of sedimentary rocks and the origin of fossils, which unlocked the history of the Earth. He left the study of science to become a priest. Eventually, he was made a bishop. He was known for his rigorous asceticism and concern for the poor, and he was declared blessed by Pope John Paul II. So he's Blessed Nicholas Steno. Marin Mersenne, a friar of the Mennonite order, these are all figures in the 1600s that I'm starting with, is considered the founder of acoustics for fundamental discoveries in the theory of sound and vibrations. He also made important contributions to the theory and design of reflecting telescopes. His religious house became a meeting place for famous scientists, and his voluminous correspondence with other scientists was an important means by which scientists of his time learned of each other's work. This was before the internet, this was before scientific journals, scientific conferences. So it was by correspondence that scientists communicated with each other, and a central hub of that correspondence was Marin Mersenne. The Dictionary of Scientific Biography calls him one of the architects of the European scientific community. A Jesuit astronomer, and this is a picture of him, a drawing of him, a woodcut, I suppose, was one of the discoverers of sunspots and made the most detailed studies of them. Okay. There's actually a picture from his treatise on sunspots. Giovanni Battista Riccioli, another Jesuit scientist of that era, developed an extensive star catalog and together with his fellow Jesuit Francesco Grimaldi, made the first map of the moon's surface. He developed methods for measuring time precisely in experiments and made the first accurate measurements of the acceleration of gravity on the surface of the Earth. It was recently found that Riccioli discovered the important Coriolis effect, which all physics people here will know about. The Coriolis effect was named after someone, Coriolis, in the 19th century, but actually Riccioli discovered it 200 years earlier. Francesco Grimaldi, who worked with Riccioli. How many people have heard of the phenomenon of diffraction of light? It's a central, very important concept in physics. It was actually discovered and named carefully observed by Francesco Grimaldi in the 1600s. The Benedictine priest Benedetto Castelli was a friend and student of Galileo, did foundational work in hydraulics and fluid mechanics. He had a much more famous student, Torricelli, who discovered the principle of the barometer and was the first person to correctly explain the causes of wind. Bonaventura Cavalieri, another student of Castelli, and was himself a priest, made important developments in the foundations of integral calculus. Here's a quote: "Calculus was discovered independently by Newton and Leibniz himself paid tribute to the work of Cavalieri and Torricelli." Spallanzani is considered one of the top biologists of the 18th century. His contributions to biology are too numerous to mention. Another priest, René Just Oey, is considered the founder of crystallography. The first asteroid was discovered by an Italian priest astronomer named Giuseppe Piazzi. Ceres is the asteroid that he discovered. It's actually the largest of the asteroids. There's some pictures taken by NASA. It has been reclassified recently as a dwarf planet. So you might say he discovered one of the first planets discovered in modern times. The Jesuit priest Angelo Secchi is considered one of the founders of modern astrophysics. Astronomy studies where things are in the sky. Astrophysics studies what are these things, how do they work, what are they made of, and so on. And one of the chief tools in astrophysics is studying the spectra of light that come from these objects. One of the pioneers of using spectroscopy in understanding the sun and the stars was Secchi, and he made the first classification of stars based on their spectra, which is the basis of the classification that is still used by astrophysicists today. The Czech priest Bernard Bolzano helped put modern mathematics on a more rigorous footing. Anyone who studied advanced math has heard of the Bolzano-Weierstrass theorem. The Stanford Encyclopedia of Philosophy called him also the greatest logician in the period from Leibniz to Frege, which is a 200-year period. So he was a major figure in mathematics. Of course, the science of genetics was founded by the Augustinian friar Gregor Mendel. Well, if I were speaking at Notre Dame, I would mention him. He was a professor at Notre Dame. Georges Lemaitre, who is the gentleman, the cleric in the first picture I showed you, is the founder of the Big Bang Theory. That is our picture of the universe and its history, is the Big Bang Theory. That theory was first proposed by a theoretical physicist who is also a Catholic priest, Georges Lemaitre. Okay. All right, so that's the history side of my talk. So the thing is, the bad news makes the headlines. So everyone's heard of, I talk to Catholic audiences a lot. What name comes to mind, I ask them, when you think of the Catholic Church and science? Galileo. In the 800 years, the Catholic Church has been interacting with science. In the 400 years, it has been interacting with modern science. That's the only name people have heard of. Most people heard of Mendel. They haven't heard of Georges Lemaitre, who founded the Big Bang Theory, or all these other important scientists who founded other branches of science or made important firsts. Like one of the ones I mentioned, I forgot to say, he was the first person to measure the speed of sound. Okay, so enough of the history. Let's get into some physics, which is my favorite subject. And I have 12 minutes to tell you about the physics of the 20th century. So let me mention some discoveries of modern physics that seem more in line with a Christian view of the world, or a theistic view, than with materialism and atheism. I refer you to my book, Modern Physics and Ancient Faith, which is, I'm told, on sale actually outside here, if you are really a physics junkie and you want to learn more about this. One discovery of the 20th century had to do with the beginning of the universe. The Jewish and Christian view was that the universe had a temporal beginning, that it had a finite age. By contrast, the pagan philosophers of antiquity, including Aristotle, believed that the universe had always existed for infinite time. It had no temporal beginning. And most modern atheists have also preferred that view of a past infinite universe. As of 100 years ago, the scientific evidence, by and large, seemed to suggest that the universe had always existed. And many people came to regard the idea of a temporal beginning of the universe as just a relic of religious mythology. But now we know that Georges Lemaitre's idea of a Big Bang was correct. There was a Big Bang about 14 billion years ago. And in the standard theory of cosmology, that was the beginning of the universe and of time itself. Now, it's quite possible that something existed before the Big Bang, that there was a prehistory of the universe. But even if that is the case, and there are interesting speculative scenarios where that is the case, there are strong theoretical arguments that favor the idea that the universe had a beginning at some point. If not at the Big Bang, then at some earlier point. The weight of theoretical argument is in favor of a universe with a temporal beginning. A second discovery has to do with our place in the universe. For a long time, atheists have said that the evidence shows or indicates that human beings are just a cosmic accident, a fluke, in a universe that is totally without purpose. But over the last few decades, physicists and other scientists have become increasingly aware that many features of the fundamental laws of physics, as we know them today, and the structure of the universe seem to be just right to make the existence of life possible, of complex life. If certain things had been even slightly different about the laws of physics, then we wouldn't be here. These are fortuitous features are often called anthropic coincidences. They suggest to many people that we aren't an accident and that the universe does have a purpose, namely that beings like ourselves should arise in it. One could mention many examples of such anthropic features of the universe and its laws. A famous one has to do with a strong force that binds protons and neutrons together to make atomic nuclei. If that strong force were only a little bit weaker, say 25% weaker, it would not be weak. Most of the elements of the periodic table would not exist. In fact, only hydrogen would exist. The same is true, and you can't make living things, most people believe, out of just hydrogen. You need a much richer palette of chemical elements to make living things. The same is true if a certain energy level of the carbon-12 nucleus had not been very close to its actual value, a few percent or one direction or the other, and we've had virtually no elements heavier than helium, or maybe lithium. The fact that the world it's not just fine tunings like at this energy level of carbon-12 or the strength of the strong force. Many gross qualitative features of the universe are also very important for the possibility of life. For example, the fact that there exist 3 large or extended dimensions of space. There could be others, but they would be subatomic in size, scale. But there are 3 large spatial dimensions. That's crucial. The next thing is something that I wrote a paper on, which is the strength of the Higgs field. You've heard of the Higgs boson, or the Higgs particle, or the Higgs field. The strength of the Higgs field, in the jargon, it's vacuum expectation value, has to be in a very, very narrow range. Otherwise, it would not have virtually no possibility of life. And one can go on and on. An interesting case is the size of the universe. It's often pointed to as an example, as showing our insignificance. If we're important in the cosmic scheme, why did God create all that unimaginably vast empty space out there? We're just a tiny, tiny, tiny speck in this universe. In fact, the size of the Earth compared to the observable universe is like the size of one drop of water compared to all the oceans in the world. So how can we be important? Well, it turns out the vast size of the universe is a precondition for us being here. It took billions of years for biological evolution to produce creatures as complicated as we are. Before evolution could even begin, or life even began, it took billions of years of astrophysical processes to produce the chemical elements which are needed to form life. So you need the universe to last for billions of years. Now, if the law of gravity is Einstein's law of gravity, there's a relationship between how long a universe lasts and how big it gets. Suppose you said, God, wasted all that. God should have made a universe that was human scale. He didn't have to create anything bigger than, say, Earth. But if the universe had never got to be bigger than Earth, it would have lasted for about 100th of a second. Even if you say, well, God could have created a universe the size of the solar system, which still is unimaginably vast compared to us, a universe that never got bigger than the solar system would have lasted a matter of hours. If the universe is to last for billions of years, it has to be billions of light years across. So that size, far from testifying to our insignificance, is a precondition, as I said, for us being here. So, I still have 5 minutes. Okay. Now there is, I should say, to be fair, and I discuss this at great length in my book, there's a naturalistic way, without invoking God or some cosmic purpose, to account for many of these anthropic coincidences. And it's the idea of the multiverse. I won't talk about it unless I'm asked in the Q&A. Some religious people mock the multiverse idea, and they think it's some sort of atheist plot. It was some idea that was hatched by atheists simply to find a loophole and to explain these things without invoking God. Well, it's actually a very serious idea. I think there's a very good chance that it's true. And I think a lot of physicists think there's a good chance that it's true. But even if it were true, it doesn't completely vitiate the force of the argument that the fundamental structure of the laws of physics and of the universe are peculiarly suited to have living things arise. And the point is that to have a multiverse, the laws of physics also have to be very special. So you need special laws. If you're going to go out someday and make a universe, and you're picking some laws to base your universe on, you got to pick very special laws. You're not either ones that give you a multiverse, and that's a non-trivial thing, or ones where various parameters are fine-tuned and various features are built in. You have to have special laws, or you're going to get a universe which is completely devoid of life. That doesn't prove anything, but I think it's suggestive. A third development in physics is that the laws of physics have been found, as time has gone on, we have found that the laws of physics are based on very deep mathematical ideas. And the more we learn, the deeper those ideas are seen to be. So let's take an example. Kepler, as I mentioned, discovered 3 laws of planetary motion. Very beautiful laws. They can be explained if you get in maybe 15 minutes to a middle school student or a grade school student. Beautiful mathematically, but not that deep. But Kepler's laws of planetary motion are really based are a consequence of deeper laws, which are Newton's laws of gravity and mechanics. To understand Newton's laws of mechanics, you really have to understand calculus, so deeper math. But we now know that Newton's laws of gravity are really an approximation to a consequence of yet deeper laws, which is Einstein's theory of gravity, general relativity. General relativity requires that you know about curved, four-dimensional, Minkowskian, that is non-Euclidean, space-time, which requires, differential geometry and tensor analysis and so on. So you learn that in graduate school. Usually I take a 1-semester course at least to really grasp the ideas of general relativity. But it is now believed by a lot of the top people, and I tend to think that this is true, that Einstein's theory of gravity is based on something called superstring theory. It's almost certainly based on a deeper theory. It's an approximation of deeper theory. That deeper theory is very likely to be superstring theory. Now, the mathematical structure of superstring theory is so deep that even though you've had thousands of the world's most brilliant mathematicians and mathematical physicists and particle physicists studying it intensively since 1984, they still don't really have their arms around its mathematical structure. They feel that they've only sort of scratched the surface of it. So you see, the laws of physics, the universe is not put together with Tinker Toys and Legos. It doesn't have some sort of trivial structure to it. Its structure is based on very profound and very subtle mathematical ideas. That would seem to suggest that perhaps there were the thought of a very profound mind. So I'm not going to skip, I will just actually make one quote, and maybe end this. Oh, did I have it? Yes. Hermann Weyl, one of the great mathematicians of the 20th century, who also did very important work in mathematical physics, gave a lecture in 1931 at Yale University in which he said, "Many people think that modern science is far removed from God. I find, on the contrary, that it is much more difficult today for the knowing person to approach God from history, from the spiritual side of the world, and from morals. For there we encounter the suffering and evil in the world, which it is difficult to bring into harmony with an all-merciful and almighty God. In this domain, we have evidently not yet succeeded in raising the veil with which our human nature covers the essence of things. But in our knowledge of physical nature, we have penetrated so far that we can obtain a vision of the flawless harmony which is in conformity with sublime reason." And I'll just mention two other big discoveries of the 20th century. Well, actually, one discovery which has two very profound implications. That's quantum mechanics. One reason many people lost their religious faith in the 1700s, 1800s, was the belief that the laws of physics were deterministic, that the equations of physics rigidly controlled everything that happens. And in fact, all the laws of physics that were discovered up until the early 20th century were deterministic in character. That is, their equations were such that if you knew the state of the world at one time in absolute detail, the equations uniquely determined everything that would happen thereafter, and actually everything that happened before. So everything happening now would be the unique consequence of what was going on, say, 5 billion years ago. Whether I lift this up, what words are coming out of my mouth, what you're doing, what you're thinking, would all be the consequence of the state of the world 5 billion years ago and these rigid laws of physics. Quantum mechanics overthrew determinism. It showed that the laws of physics do not uniquely, given a situation, the laws of physics do not uniquely determine what's going to happen thereafter. It only determines what things can happen and their relative probabilities of them happening. That's a very profound change. As I said, many people had lost their faith because of this determinism, belief in determinism, because it seemed to rob us of the possibility of free will. And the second consequence of quantum mechanics, which that is essentially universally agreed upon, but a second consequence, which I don't have time to discuss, is that according to a certain very powerful set of arguments, quantum mechanics implies that not everything that goes on when a measurement is being made is describable by the equations of physics. And I'll just quote a couple of, well, two famous physicists and a well-known philosopher of physics. Sir Rudolf Peierls was an important physicist of the 20th century. Eugene P. Wigner was a Nobel Prize winner in physics. Peierls said, "The premise that you can describe in terms of physics everything, the whole function of a human being, including its knowledge and consciousness, is untenable because of quantum mechanics. So we're not completely describable by physics." And Eugene Wigner said, "Materialism is inconsistent with present quantum mechanics." That's a long story. Actually, you can watch a YouTube video about 40 minutes long where I explain that argument. But anyway, so there are profound anti-materialist arguments coming from physics itself. that have to be taken seriously. And I think I'll stop there and just say that far from what people think, Christianity, Catholic Church in particular, has been a friend of science, greatly contributed to science, and many things that science has discovered actually sit better with a traditional Christian view of things than with atheism and materialism. Thank you. I love physics questions especially, but I'll entertain others too.
Thank you for your talk.
Yeah.
I was wondering if you could speak to the idea of the quantum creation of universes
Yeah.
and just explain what that is
Okay.
and your thoughts on that.
Okay, I actually like the idea a lot. And I tend to think that there's a good probability it's true. It's a description, basically, of what went on physically at the beginning of the universe. And it says, and I don't want to go into the physics, though in private I'm willing to do that. It says basically that the universe had a beginning in time and it sort of began in something called a quantum fluctuation. Now, instead of going into the physics of that, which I actually do in Appendix B of my book at great length, I explain all that in pretty, I think, accessible terms. Let me just explain why it's nothing to do with creation. This is a hugely important point. The creation of the universe is one thing, the beginning of the universe is another. They're not the same idea. Now, admittedly, in Genesis 1:1, it says, "In the beginning, God created the heavens and earth." But they're two distinct ideas. And the way to get that across is, again, with the analogy of a novel or a play or a piece of music. A symphony, well, the beginning of the symphony are the notes. The symphony has an internal sequential structure, which is a set of notes. The first notes in that sequence is the beginning of the symphony. But the creation of the symphony is the conceiving of it in the mind of the composer, who gives it being. In Christian thought, creation is conferring of being upon the universe. It's making it a real universe, as opposed to a merely hypothetical or fictitious or possible universe. It's what creation is the answer to why is there any universe? Why is there a real universe and not just a hypothetical one? God confers being. So what gives being to the symphony, what sort of the conception of it that gives it being as a work of art, happens in the mind of the composer. The beginning is just a bunch of notes. And the creation and the composer is equally responsible for all the notes of the symphony, not just the ones at the first ones, but the last ones and all the ones in between. All of them are equally created, in a sense, by the composer. Same with the book. The beginning of the book, A Tale of Two Cities, are a set of words. It was the best of times, it was the worst of times. Those are the first words of the novel. But the creation of the novel, answer to the question is, why is there a novel, A Tale of Two Cities, is Dickens in his creative activity. So if somebody said to you, why is there a book, The Tale of Two Cities? If somebody said, oh, because it was the best of times and the worst of times, those words, that's silly. If someone says, why is there Beethoven's Fifth Symphony? And somebody said, oh, look, da-da-da-da-da-da, that's lunacy. Those are not the cause of the being of the work. Those are the initial moment. So the creation of the universe is God's giving being to the whole universe, all of it. The beginning of the universe is just some set of events that happened first in the sequence. Now, would you expect the beginning of the universe to be something miraculous in the sense of something that broke or violated or were contrary to the laws of physics that governed the rest of the universe? No. Any more than you would expect the beginning sentence or words of a novel to be, they would expect them to obey the same laws of grammar as all the remaining words of all the other words in the novel. You wouldn't expect them to have their own different laws. So, frankly, I think it's that the beginning of the universe was a natural event in the sense that whatever happened at that time, and which is still not understood, what happened at that time if we ever understand it, we will find that it is in conformity with the same laws of physics that apply everywhere else. So the idea that God, many people's idea of creation is a deistic one, where God is, again, not the author of nature, but actually like a super being, a superhero who's really inside the world, lighting matches and setting off big bangs or something. No, God is not a cause, as I said, a horizontal cause within nature. He's not someone who is tinkering around and pushing and pulling on matter and doing strange, miraculous things at the beginning, as if he were just some part of nature. He is the author of it. He conceived the universe, all its laws and events, and gave being to them. So that's the important, but the details of quantum fluctuations I'll leave to another time. Yeah. Back there. There are two back there, but whoever.
Hi, I was just wondering about some of your thoughts on this idea of a self-created universe in which they acknowledge that there's a singularity in which all these things are formed. However, they remove the idea of the author out of it, so there is just the vertical line. It's more like a loop instead of the horizontal line more like a loop at the beginning instead
You're
of the
talking about a
vertical
universe
line.
that goes around in a loop.
No, more like the idea that the universe is self-created in a sense, because that has been kind of throwing around recent years.
No, but you see, okay, I think I sort of already answered it, but let me give you an analogy to make it even clearer. Hawking actually had the right answer to that in his famous popular book that he wrote in 1988 called A Brief History of Time. There he was thinking very clearly and put his finger on precisely the right question. What he said at that point is, all that physics gives you is a set of mathematical rules and equations, and that is true. Physics, theoretical physics, gives you, the theories of theoretical physics are sets of mathematical rules and equations. So he said all that any theory of physics gives you is a set of mathematical rules and equations. It cannot, he said, answer the question of why there is a real universe for those equations to describe. Now later, somehow he forgot that, and in his last book, written in 2010, or co-authored, he said that the laws of quantum gravity can explain why there's a universe. But he was right the first time. And I'll give you a simple analogy that will make this clear. First of all, he was right, and I don't think he would ever have repudiated the idea that physics is just a set of mathematical rules and equations. I could have the rules of, let's say, the game of baseball in a book. So here I'm holding the rules of baseball. They tell me what kind of events happen in a baseball game, in what order they happen, which events cause other things, which events cause other events. 3 strikes cause the batter to be out. He gets hit by a pitch, he goes to first base. It tells you how baseball games unfold. It even tells you how they begin, and it tells you how they end. But the mere rules of baseball do not tell you, and whether there ever has been, is, or ever will be an actual real game of baseball played. Nor do the rules of baseball have the power to bring into being a real baseball game that is described by those rules. In the same way, as Hawking once pointed out, the rules of physics are the rules of this game we call the universe. They're the rules of the game. Those rules do not have the power to make there be a real universe described. They could be describing fictitious or hypothetical universes. In my job, what we do all the time, every day, is our theoretical particle physicists are cooking up rules of possible universes, laws of physics of possible universes, which we hope will turn out to be the rules of our universe, and we'll get a Nobel Prize. Sad to say, 99.99% of the hypothetical laws that are cooked up by theorists turn out not to be the rules of our universe. We know that the rules we have in hand are almost certainly not the ultimate laws, so we're trying to find them. It could be superstring theory, grand unification, There's all sorts of theoretical ideas out there. They are the rules of possible universes, but what makes a certain set of laws the rules of an actual universe, not just of a possible universe? That's the question of creation, which, as Hawking pointed out, the mere laws of physics cannot answer. Now, it may be no answer. If you ask, why is there a real universe for the laws of physics to describe? It could be there's no answer. Perfectly logical to say it's a question with no answer, and you could be an atheist. Or you could say, well, God is the answer. He gave being to the universe. Those both make sense. I think the latter answer makes more sense. But it makes absolutely no sense to say that the laws of physics are the answer. I'll maybe leave it there.
Based on the idea that humans are made in the image of God, does that make human evolution different than the evolution of other species?
I'm going to give you the Catholic answer to that.
Okay.
In Christian tradition, going back to very early times, it's been consistently held that what most makes us in the image of God is that we are rational, free creatures. And that only, among terrestrial creatures anyway, only human beings have reason and free will. That makes us also, and again, this is the Catholic answer, and I think most Protestant denominations, Christian denominations, have the same or similar answers. This also is what makes us spiritual beings in the image of God. What makes us most similar to God, that we have rationality and freedom. This, the Catholic Church says, our spiritual nature is not something that can be explained by physics or chemistry or biology. Our physical structure, we are also a structure made of atoms, the way Crick and Carl Sagan, we are made, our bodies are made of atoms, our brains are made of atoms. Our physical constitution did arise from natural physical processes over long periods of time. In other words, as the atoms got arranged in this present form by natural physical processes, but we're more than just an assemblage of atoms. That's the crucial point. We're more than that. And that more, which physics cannot explain, we believe to be a direct gift of God. And that's symbolized in Genesis, chapter 2, where God takes the dust of the earth and breathes on it, and it becomes a living soul. The early church fathers, the early Christian theologians, interpreted that symbolically to mean that there were two elements to a human being. The sort of bodily element, the physical element, which comes from dust, and the spiritual element that comes directly from God. So the Catholic Church accepts that on the physical level, we evolved, as the theory of evolution says, but something happened that was special in our case, which was God, at some point in the fullness of time, raised some of those creatures that evolved to the level of rationality and freedom, conferred on them a spiritual dimension, if you will, raising them to rationality and freedom.
So I think I followed your argument to the extent that the complexity of the universe and the order of it,
The order.
order, not complexity, imply a creator, but I'm a little confused about the jump after that to where the evidence that you can claim that this creator is a good or personal creator.
First of all, I don't want to say this showed anything. So one thing I do not like to do is say, here's an argument that proves the existence of God. I think proofs, deductive or demonstrative proofs, hardly exist anywhere outside of pure mathematics. They don't exist in physics. In physics, we do not prove things. We find a lot of evidence, and we find that this explanation is the best explanation for the evidence, but you cannot deduce the truth of Maxwell's equations of electromagnetism from any set of experiments. We don't prove things in physics. So I don't like that term, I showed that God exists. I was simply pointing to it as evidence that God exists, as something that needs to be accounted for, and many people think that the orderliness of nature, especially the deep mathematical structure of that order, is suggestive of a mind at work. You don't get from there to God being good. So when the field of theology where you argue from the natural world to the existence of a creator is called natural theology. So you argue from nature to God. That only takes you so far. It doesn't say anything about suffering, evil, sin, redemption, love, God's love. It doesn't tell you about all the important things about the Christian faith and about human life. It doesn't tell you about right and wrong. It gives you what Pascal said, called the God of the philosophers, but not the God of Abraham, Isaac, and Jacob. But still, I think if you get from being a non-believer up to at least believing in the God of the philosophers, you've gone pretty far. And then I think from there you take other kinds of arguments in favor of a God, of the nature, more about the nature of God, and these other deeper questions. But I'm a physicist, so I can only try to at least not to take you by a demonstrative argument, but to point to things that suggest the existence of God. And after all, that's all the scientific atheists, scientific materialists do. They don't claim that science proves there's no God. They don't claim that science proves there's no soul. They simply say, look at all this stuff. Doesn't that sort of point to the universe being pointless? And they don't prove the universe has no point. They simply say the evidence suggests that. And I'm simply saying, well, there's this other evidence that they're not paying attention to that suggests quite the opposite. So, yeah.
I am curious about your opinions on the multiverse in terms of, is it so that the multiverse is infinite? And if so, is it to the same degree that God is infinite? And if not, could you talk about that in terms of, like, if you really have these infinities, like, and all these possibilities, is there one where it does not necessitate a God to create one of those universes or not?
Okay, infinity, you don't need the multiverse to be infinity. What is the multiverse idea? Suppose somebody, I'll give an analogy that sort of is what motivated, well, suppose somebody came along and said, you know, conditions on this earth are perfect for life. If it were much colder, everything would be frozen. If it were much hotter, all the stuff would boil away. The gravity is just right. If the gravity were much less, the atmosphere would escape. If it were much greater, it would squash the earth and everything else. And you could go through the chemical composition of the earth and all sorts of things on the physical conditions that make it good for living things, to make it a habitable planet. And suppose all you knew about was the earth. Suppose you lived in a time, suppose the earth was so covered in clouds you didn't know that there were stars, and you didn't suspect that there were other planets. You thought this was the whole ball of wax. You would say, wow, that's amazing. So many things are just right on earth for there to be life. It's got to be that God chose all these things, the temperature and the density and the chemical composition. And then along comes a scientist and says, well, hey, wait a minute. I postulate, even though we can't see it because of all these clouds, I think out there's a huge number of other planets of all sorts of sizes and chemical compositions and temperatures. Billions of them, trillions of them. And they're going to be all different conditions on these planets, and so there's bound to be at least one of them where the conditions are right for life, when there's so many. Try enough lock keys, and one will fit the lock. And people laugh, there's no evidence for these other planets. You fool. But of course we know that there are other planets, and this is probably the correct explanation for why conditions on Earth are propitious for life. Now the multiverse idea takes this a little farther and says, all these things that we regard as traditionally thought were constants of nature, the strength of forces, the kinds of forces, the masses of certain particles, and so on, are not actually constants of nature that are that way throughout the whole universe. They are that way, there's very strong evidence that they're that way throughout the whole part of the universe we can see, called the observable universe. But the universe is much bigger than the part we can see. That's almost certainly true. And in the very remote parts of the universe that are far beyond what is called our horizon, where we can't see them, and will never see them, the conditions are quite different. The strong force does have different strengths in different places, and so forth. The masses of particles, the electron has one mass here, different mass somewhere else. And if you have enough possibilities tried out in different parts of the universe, there's bound to be some, and the universe is big enough, it doesn't have to be infinite, it's just big enough. There's bound to be some place where all these things are just right. Perfectly reasonable. What makes it more plausible, first of all, even in garden variety theories of the kind I've worked on, say, these theories go back to the early 80s, supersymmetric grand unified theories, you would have in such a theory different parts of the universe having different particles and different forces and things having different masses. So that's not such a radical idea. It's quite, so, and in superstring theory, it's even more plausible that something like this goes on. That doesn't, first of all, it doesn't mean that you explain all the anthropic coincidences. So if there's dozens of things that have to line up just right, in order to explain them away with the multiverse, all of those things would have to vary from place to place. So you might explain some of them. It's not clear you could explain all of these coincidences or the multiverse. But as I said, even if you could, to have a multiverse structure, the fundamental laws have to be very, very special. In the multiverse, things are different at a superficial level. So the electron might have one mass here and one mass very far away. But underlying all the parts of the universe, and the multiverse, I should emphasize, is a universe, it's a single universe. It's one universe with many regions, but it's one universe with one fundamental set of laws. Those fundamental set of laws, the deepest laws of physics, are the same throughout. And they would have to be very special to give rise to this multiverse structure. So, as I said, the laws have to be special in one way or another. Yeah. The whole thesis of my book, and I sort of went through a lot of it in the last part of my talk, if you had been alive, if one had been alive in the year 1900, there were certain trends in the history of physics that would have been worrisome to a Christian. That the laws of physics seemed deterministic, which seemed incompatible with free will, that there didn't seem to be a beginning of the universe, and so on. And the point of my book is that actually in the 20th century, things were discovered that seemed to make the trend lines go the other way. I call them twists in the plot. In 1900, it looks like things were moving in a certain direction, and suddenly in the 20th century, suddenly they moved the other direction. The universe did have a beginning. The laws of physics are not deterministic, and so forth. But I think the biggest, so one thing I should say, a lot of Christians and religious people live in fear of science because we're taught that science is always revolutionizing our view of things. People are afraid that they're going to wake up someday and read in the science section of the New York Times or Discover magazine, something was discovered that overturns the apple cart. Suddenly it's blown completely out of the water, religious view of it. You shouldn't think that. First of all, not all discoveries, as I pointed out, many of the discoveries of modern science have actually tended to move the other direction and sort of strengthen or move more in a religious direction rather than away from the religious picture of the world. But if we're people of faith, science follows a winding path. And in some of those twists and turns, it brings us farther away, it seems to bring us farther away from the religious picture of the world, but we should have faith that at the end of the day, when that path ends and it reaches the full story of things, we'll find ourselves with a picture of the physical world that's completely compatible with, or of the universe completely compatible with our faith, because the God who created this world is the God who created the laws of physics. So science is taking us closer and closer to the truth. I would say there's one major way in which science, as time goes on, will not inevitably, but the whole trend of science strengthens the argument for God. And that is, as I said, if you go back to early Christian writings, the two central arguments from the physical world for God was, as I said, that it exists, that it has being, that it's real. God is the cause of being. And two, it's orderly and lawful. As physics has progressed, we're always seeing that the order of nature is greater than we imagined, more sophisticated, more impressive, more beautiful. And that has been going on for 400 years. And, and I think all physicists expect it will continue to be that way. The more we learn about the physical world, the more remarkable the order we find. So that's always strengthening the case for God. Okay.